Hi, I'm Ming, and this is Kitchen Matters. We're a team of material science grad students helping you explore the mysteries of food. In this video, we're going to take a deeper dive into the crystal structure of chocolate. This will eventually lead us towards understanding how chocolate is tempered and how you can make your very own chocolate art in your kitchen. Let's begin by reviewing the composition of chocolate. The chocolate we buy at the store contains particles of cocoa solids that are scattered throughout cocoa butter. Depending on the type of chocolate, there may be additional flavorings such as milk powder and sugar. The cocoa solids are responsible for giving chocolate its flavor and dark color, whereas cocoa butter gives chocolate its smooth texture. Now, in particular, chocolate makers spend a lot of time thinking carefully about the crystal structure of cocoa butter. That structure can make the difference between a crumbly chocolate bar that just melts in your hand or a firm one that snaps when you bite it. Cocoa butter is a type of fat, made up of 3 types of fatty acid molecules, which I've shown on the screen. These fatty acids are grouped together into larger molecules called triglycerides, where each triglyceride contains 3 fatty acid molecules. Since chocolate contains 3 different types of fatty acids, a range of different triglycerides are possible. You might get a triglyceride where the fatty acids are combined like this, or maybe one like this, and so forth. You get the picture. For simplicity, from now on I'm just going to draw all these triglycerides as these cartoonish sticks, since all these molecules generally have similar overall shapes. Importantly, the triglyceride molecules in cocoa butter can pack together into a regular pattern and form a crystal. For example, you could imagine the triglyceride molecules packing into this pattern, or maybe they could pack like this. As you can see, we can really imagine many possible ways for the triglyceride molecules to pack together. In fact, scientists have discovered that cocoa butter has 6 main crystal structures. In other words, there are 6 ways that the triglyceride molecules tend to pack together. Because cocoa butter has multiple crystal structures, we say that cocoa butter is a polymorphic material, meaning it has many structures. Each crystal structure is also called a phase, and scientists have assigned each phase a number from 1 to 6. These phases of cocoa butter are all made of the same triglyceride molecules. However, different phases have different arrangements of those molecules. As you go from phase 1 to phase 6, the triglyceride molecules are packed more tightly together. So here's a question for you. Which phase of cocoa butter would you expect to have the highest melting point, phase 1 or phase 6? The answer is phase 6 cocoa butter. Thinking back to the material science tetrahedron, the more tightly packed the molecules, the more energy we need to pull them apart, and therefore the higher the melting point. In fact, as we go from phase 1 to phase 6 cocoa butter, the melting point of the cocoa butter and therefore the chocolate gradually increases. That means that chocolate made of phase 1 cocoa butter will have a lower melting point than chocolate made of phase 6 cocoa butter. For example, if I had a sample of just pure phase 1 chocolate, its melting point will be 17 degrees Celsius. That means the chocolate would be solid below 17 degrees Celsius, but it would melt as soon as the temperature exceeded 17 degrees Celsius. Now, this is actually very undesirable because room temperature is generally around 25 degrees Celsius, which is therefore above the melting point of phase 1 cocoa butter. This means that phase 1 cocoa butter would just melt in your hand. You can already begin to see that some phases are less desirable than others. So that just isn't the performance we're after. The ideal performance of a chocolate bar would be one that is solid at room temperature, so you can still hold it in your hand, but melts after you put it in your mouth, which, like the rest of our body, is around 37 degrees Celsius. That means we want a melting point that's closer to body temperature. Based on this criterion alone, this means that the ideal crystal structure would be something like phases 4, 5, or 6. But wait, we can narrow it down even further. Another criterion for chocolate performance is that it should have a good snap when it's solid. Let's think about the mechanical properties of the different phases of chocolate. Here's another question for you. Which phase of cocoa butter would you expect to be the strongest, phase 1 or phase 6? The answer is phase 6 for all the same reasons as before. If the molecules are packed more tightly together, the overall material will be stronger. In fact, there have been lots of experiments comparing the properties of these different phases, and I've shown one set of observations on the screen. See how phase 1 chocolate is very soft and crumbly, as we would expect, whereas phase 6 chocolate is very hard. It turns out that phase 5 chocolate is the one that has the most desirable snap, whilst also having an appropriate melting point, such that it stays solid in your hand but starts melting in your mouth. Now for the fun part. Let's characterize and do a taste test to see what difference these crystal structures make. Here I have some chocolate containing phase 5 cocoa butter, and here I have some chocolate containing phase 4 cocoa butter. You'll learn exactly how we make these specific phases in our next video on tempering chocolate, but for now let's just focus on their properties and performance. As you can see, the phase 5 chocolate has a good snap, and it also has a good shine to it, which is a property of these phase 5 cocoa crystals as well. In contrast, the phase 4 chocolate doesn't have that snap, melts a bit more easily, and the color is also duller. This leads us to a bit of a sticky situation. We've established that cocoa butter can form 6 different crystal structures, but really we only want phase 5 cocoa butter in our chocolate product. In fact, if I just took a bowl of melted chocolate and left it to cool to room temperature, allowing the chocolate to solidify, it's likely that a mixture of the different phases would form. You'd probably get some patches of phase 4 chocolate mixed with some other patches of phase 5 chocolate. How do chocolate makers ensure that their product only contains phase 5 chocolate and not any of the others? That's a question which will lead us to tempering, and so let's leave this on a cliffhanger and answer that in our next video. For now, what did we learn today? Cocoa butter is polymorphic, and the triglyceride molecules that make up cocoa butter can adopt 6 main crystal structures. As you go from phase 1 to phase 6, the triglyceride molecules are packed more tightly together, making the chocolate have a higher melting point and also become harder. Finally, phase 5 chocolate is the one that has the most desirable properties. In the next video, we'll find out exactly how we manage to form phase 5 chocolate, and we'll do lots more experimenting in the kitchen. See you then.